Hello, this is Edgar Shane, and we'll be talking about remote production over the internet today with JVC Connected CAM series of camcorders. JVC introduced Connected CAM series camcorders several months ago. These cameras feature built-in encoders, so they can send broadcast quality video transport over the internet to the remote studio location. There are also built-in decoders to receive return video, complete remote control over the internet, and all products feature broadcast quality video transport using SRT protocol. This presentation is not about this lineup as a camcorders. These cameras have so many features and applications built in, but it's really deserves separate presentation to talk about every feature and all applications. Today we will mostly concentrate on the remote production and everything associated with that. At the same time, I'd just like to briefly mention that product line is comprised of 4 models. There are 3 handheld models and 1 shoulder type camcorder. Handheld models include GYHC 500, which is the base model, GYHC 500 SPC, which adds ability to overlay live score on the picture or recorded image or live stream. And also there's GYHC 550, which features built-in wireless communication with the MIMO antennas. GYHC 550 and GYHC 900, they both have built-in Wi-Fi, while GYHC 500 and 500 SPC require small USB to Wi-Fi adapter. All handheld cameras are equipped with a 1-inch CMOS sensor capable of up to 120p slow motion recording and HDR processing, 20 times and up to 40 times in HD mode zoom lenses, and all cameras can record 4210-bit on SDXC cards. The GYHC 900 is our flagship. This is 3 2/3-inch CMOS camcorder, also capable of 120p and HDR, with a B4 lens mount, which can take every standard broadcast B4 lens, and those super zooms, which are typically used by our sports customers. GYHC 500 also records up 4210-bit on SDXC cards. All cameras are equipped with the SRT transport to send broadcast quality video over the internet. Before we dive into all the tools and all the details of the live production over the internet, let's talk about live video production in general. When you need to cover a live event, you normally would bring all equipment on location, which includes video switchers, audio mixers, all power equipment, cables. You need to bring people to set up this equipment and tear it down when event is over. And this takes place, obviously, and it requires special room. If space is not available, you would bring production truck. But in any event, it will be all switched and produced on location, and then program output would be sent to local TV channel, network, YouTube, Vimeo, whenever it needs to go. Idea that you may not need to bring everything on location, but maybe cameras only. This idea of remote live video production is not new. There are certain workflows which always required to have cameras only. Think of New York City Marathon. You have to have cameras along the course, and they would be contributing ISO feeds to the studio. There are many benefits of remote production. First of all, you need to have minimum equipment on location and maybe cameras only. You also need minimum staff on location. I talk to customers every day and they tell me that 2 people can actually set up and operate 4 cameras. And as a result, there are minimum shipping and travel expenses. At the same time, back to the remote, or sometimes they call this workflow at home. Back at home, because you are at home at your standard studio location. So back at home, you have truly unlimited resources. You have all your video switchers, audio mixers, replay servers, special effects, power, air-conditioned environment. So it is convenient to be at home at your central studio location. And you can also produce multiple events from the same location, because who said you cannot have multiple video switchers, or you can produce events very close back to back. The question is, how do you send ISO feeds from location to the remote studio? It used to be satellite, microwave, but these days high-speed internet is available everywhere, and naturally this becomes the media to carry your high-quality video feeds from point A to point B, and this point A and B can be separated by thousands of miles. So what do you need on location to send remote feeds? Well, it's actually quite simple. You just need encoders. So the broadband output of the cameras, which could be SDI or HDMI, needs to be encoded, H.264 or JVC. And these feeds are routed through the internet to the remote studio. And at the studio you would have decoders, either hardware decoders, which receive stream and output SDI, or decoders built into the video switchers. And obviously you need to have one encoder per camera, because each encoder is equipped with one input. If you're setting up 5 cameras, you would need 5 encoders. You need all the wiring. You would also need to have some kind of computer, laptop, because typically encoders, they have a web interface, so you need to log in to each encoder separately to start and stop encoding, and also to change parameters like resolution, destination IP address, and other. And you obviously need cabling, and you still need people to monitor the status of this process. And so it's like you are now producing remotely, but you still need a lot of stuff on location. That's why we at JVC, and we're making cameras. For the last 40 years, we've been manufacturing cameras. And we were thinking, how can we contribute to this workflow to make it easier to save cost and time on location? And that's where the Connected CAM lineup was built. We developed cameras with the built-in encoders, so you don't need to have outboard encoders. We added built-in decoders, so now there's something unique. You can even receive return video feeds and display them in the camera, EVF or LCD. And also built-in connectivity in form of LAN or Wi-Fi. So now on location, you really don't need anything but cameras. So you have 2, 3, 4, 5 cameras. You simply connect LAN cable to the internet router, and you can immediately start sending live video to the remote studio, receiving return video, which can be in form of prompter or program feed. And also this equipment can be remotely controlled over the same internet connection from the studio. And if LAN cable is something which is undesirable, you can even use Wi-Fi, because cameras are equipped with either built-in Wi-Fi, or some models require USB to Wi-Fi adapter. With that, you can connect to the facility Wi-Fi, or you can connect to external 4G, 5G LTE routers if you don't have wired internet. And again, your workflow doesn't depend on what type of connection it is. As long as internet connection is there, you can send video, receive video, and have remote control of this equipment all the way from the studio. Each Connected CAM series camcorders features 3 completely independent devices built in. First of all, these are standard camcorders, and therefore there's a recorder built in which records 10-bit 422 H.264 video on SDXC cards, so you can always use it later for traditional way production. In addition to that, there is IP encoder, which is completely independent from recorder. It compresses video with the H.264 and then sends SRT transport to the remote studio. And in addition to that, the third module is return decoder, which can now receive return video, which could be prompter or program output, and display it in the viewfinder or external SDI monitor. There's also 2 channels of return audio, which can be used for IFB to provide communication between producer at the studio and talent, cameraman, or both on location. And all this equipment can be controlled remotely over the same connection. We have complete RCU of the camera over IP as well. Well, enough theory. Let's jump to a live demonstration. I have JVC 550 camcorder in my home office today, and you can see it is equipped with a built-in Wi-Fi with the MIMO antennas. And I'd like to show you how this camera can send live stream to the remote studio location, and also how this camera can receive return video and also be controlled over the internet. For that purpose, I set up the video switcher at the remote office, which is actually about 50 miles from my home office at our JVC New Jersey office. And I set up vMix video switcher. I could have used TriCaster, could have used JVC CAM IP switcher. The reason I'd like to demonstrate vMix today is not only because it's amazing software with so many features built in, it's also because vMix offers 60 days fully functional trial, which means you can download this software today and start testing remote production workflow pretty much immediately after this presentation. So I have JVC 550 on my desk here, and I have remote switcher at the JVC New Jersey office location. In order for us to see this switcher, I'll be using just regular PC remote, and my choice is Parsec, which is designed for video gaming, and it's very well suitable for video applications. You'll be able to see video real time using Parsec remote. At the same New Jersey office studio, I also set up prompter with the laptop and the encoder, and we'll be able to receive this prompter on this camera as well. So here's the camera on my desk, and this is the vMix control surface, which I'm controlling remotely using Parsec remote control. And you can see this is pretty much standard video switcher, very similar to TriCaster or JVC CAM IP series. I have multiple video sources here, and one of the inputs I reserved for SRT, and that is going to be SRT listener input, and camera will be SRT caller. So camera will be pushing stream to the switcher. So on the camera, I already programmed the IP address of the remote switcher. So all I need to do, I just need to press online button, which is located right here, and video will appear in the switcher. So I'm pressing online button. Tally actually goes on, so you can see the tally light here. And now when I switch back to my switcher, you see video is already available as a video input. And this is live video from my camera right here, with the latency is about 1.2 seconds in this case. And this video appears as a regular video input for the video switcher. You can always switch it to any other video input. You can introduce special effects with this video. Just so we know that this is the program output of vMix, which we're controlling remotely, I'd like to add this overlay. So we know that this is output of the vMix. Now I'd like to go back to my camera here, and my camera is now sending live stream to the remote switcher, and we can actually see the stream right here. And you can see the stream is live with the latency about 1.2 second. But that's not it. In addition to sending live video, I'd like to show that we can also receive return. And I have return video encoder at the same location with the switcher, and that IP address of that encoder is programmed in the camera as well. So now I'm just pressing the return button here on the camera, and return is already being received now, and what I can do now, I can swap the live view and the LCD and EVF with either live view, which we have right now, or I can press view on the return, and I should be able to see return here. So now you see this is the prompter which is coming from Remote Studio, and this is also live stream which is being sent to Remote Studio. And you can actually see that this camera is right now not connected to anywhere. It's running, it is connected to the Wi-Fi. There's no cables. So camera is at my home office location, connected to my facility Wi-Fi. It is sending stream to the remote switcher, and it's also simultaneously receiving video, return video, and you can see it in the LCD and viewfinder. I can also connect external monitor with the SDI cable to this camera here. And in that case, return video will become also available on the external monitor. So camera is sending video, receiving video, and we're looking at the external monitor. All I can do now, I can also press recording. And now I'm recording. So simultaneously, this camcorder right now is sending live video to the remote switcher, receiving return from the remote encoder, which happens to be prompter in my case, and also recording 422 10-bit to built-in SDXC card. All three functions are completely independent. I can stop recording anytime. I can stop streaming while continuing to receiving return, and I can stop return, go back to my live view, and I can start streaming again. And all three functions are completely independent. I can also change sources. Not only camera can send video to multiple destinations, but I can also change sources for the return video. Instead of prompter, I can go in the menu and select maybe TV station feed. That's how simple it is. And you enable your return again and press button to view return. And now, instead of prompter, I'm looking at the output of the TV station feed. And again, while simultaneously sending video and receiving video return. It's all happening at the same time, and recording. Let me press record button. All simultaneously connected to facility Wi-Fi. Camera can store up to 4 streaming destinations and also 4 sources for return video. It's all preset and programmed in the camera. When on location, it's very simple to access these settings just simply by pressing the menu. You can see stored destinations where to send streaming video, and it could be you can rename those destinations. It could be Studio 1, Studio 2, vMix, TriCaster, decoder. Cameras can also stream directly to YouTube, Facebook, or to Amazon Cloud. Regarding return, there's also 4 sources of return which could be renamed, and they are programmed in the camera, so you can pull return from 4 different destinations. Could be destinations, could be 4 different encoders in the same studio. Programming camera to send live video to the switcher can be done either with the menu and the LCD or by accessing camera via web remote control. But regardless of how you do it, you need to program the IP address of the remote studio here, because camera will be pushing SRT caller mode, means camera will be pushing stream to the remote studio, to the remote switcher. You also need to select port. There could be any port. In our case, we selected port 9005. You also set up latency, the latency allowance. You remember that we were talking about how much latency you would let repeat request protocol, SRT, error correction protocol, to correct all the errors. On the receiving side, and this example is with the vMix video switcher, it's again quite simple. You need to add input, and there's a convenient button to add stream SRT. You select stream type, SRT listener, because remote switcher is listening to the stream. Camera is SRT caller. Must be the same port, 9005. Latency, and also decoder delay. vMix, they call it delay, but in reality, it's not a delay, it's a buffer. And you always need to have buffer to compensate for jitter. So with our camcorders, we recommend to have decoder delay 300 milliseconds to assure smooth video. This IP address here is the public IP address of the studio, and if this is one of the computers connected to the router, then port 9005 needs to be forwarded to the local IP address of the switcher. The moment you press live button to start streaming, you will see real-time quality confirmation in the viewfinder. Remember that SRT provides bidirectional quality of streaming, continuous confirmation, and we take advantage of this and we display the status of this right in the viewfinder, which means that regardless of either this is the cameraman or maybe it's a talent who rotated LCD 180 degrees to see themselves, they will always be able to see confirmation of stream quality. And if this is red and solid color, that means that not only you're streaming, you're sending live video, that this video is received and quality is excellent quality. If there is something happens with the stream and it is losing data beyond ability of SRT to compensate for these errors, this indication will change color. And in worst case, if connection was lost, you will see the balloon and you will know that something is wrong, connection was lost. Camera remote control. Camera can be controlled remotely over IP by simply typing IP address of the camera in the browser. First of all, you need to press status button on the camera, and status button is located right here. So when I press status button, built-in LCD shows me the status of my connection, and you can see that I'm connected to Wi-Fi access point, and this is my IP address. All I need to do now is to type this IP address in the browser. Upon typing IP address in the browser, camera remote control appears. And you can see that from here, I can start and stop recording. I can also control zoom remotely. You can see I'm controlling zoom remotely over IP. And I can also have complete control of pretty much, I can stop streaming, pretty much any parameter of the camera. You can say I can take this camera, put it on full auto, or keep it off. I can change iris. I can introduce gain. And I can also adjust colorimetry of the camera. And I can go to a white paint adjustment, and I can do as much over IP as I can paint this camera over IP. As you can see here, I can change colorimetry of the camera, which means that somebody from the remote studio can log into the camera and touch up some settings, master black, white paint, iris, shutter, zoom. Pretty much any parameter can be controlled remotely over IP. With everything incorporated in the camera, the remote production over the internet becomes quite simple. You have either multiple or single cameras at various locations, and each camera is sending isolated ISO feed using SRT transport over the internet to the remote studio. At the studio, you have either decoder, and example would be JVC BRD900 decoder, which receives SRT and outputs 3G SDI, or you can use video switchers, which are capable of receiving SRT protocol for video over IP. And examples would be vMix, TriCaster, and JVC CAM IP series. It doesn't matter how many cameras, 2 cameras, 1 camera on location, multiple cameras. and we can actually provide multiple camera stream synchronization using built-in timecode. And also locations, where are those locations? Not important. How many locations? Not important. All ISO feeds will be routed through the internet to the remote studio. Connection on location could be wired internet, could be wireless internet, could be LTE, bonded LTE. Again, connection is completely transparent. As long as internet is available, streams will be all routed through the internet to the remote studio. And what is important that in many cases, there's no subscription fees, because if this is standard internet, then it's a monthly fee for unlimited bandwidth, so you can be sending broadcast quality feeds 24/7 with no added cost of subscription or per minute per hour fees. That's how simple it is. So video is encoded with the H.264 or JVC. In our case, encoder is built into the camera, and then decoder at the remote studio, capable of H.264 and JVC, and that's all it takes to send broadcast quality feed from point A to point B. Quite often customers ask me, what is the bitrate, how much bandwidth should be available on location. We usually recommend anywhere from 5 to 8 megabit per camera, depending on a codec. Obviously, JVC is more efficient codec, so it will be able to produce better image quality at lower bit rates. But regardless of codec, anywhere between 5 and 8 megabit per camera, because remember, each camera is sending its own ISO feed. So 5 to 8 megabit per camera will give you very good image quality on the receiving side. So it's as simple as that. However, there is a catch. The internet happens to be a public network, meaning many people use it simultaneously, and you don't have much control of what's going on the internet. It's just like any highway. I live 30 miles from New York City, and it may take 30 minutes one day, it may take 3 hours another day, because there's no idea what's going on between point A and point B over the internet. Congestion is causing data loss. Jitter, and jitter is when information doesn't arrive on time, doesn't arrive on a regular basis. All these things are causing data loss, and data loss for live video is fatal. Every time data loss takes place, video will exhibit dropouts and artifacts. That's why it becomes important how you send this data. What is the protocol you use for live video when sending it over the internet? And protocol describes how you send video. Codec is H.264 or JVC. Codec describes the compression. Protocol describes the method, the algorithm, how you send that video. And typically video protocols are well known by their abbreviations: UDP, RTP, RTSP, RTMP, and NDI. NDI is a great protocol. I use NDI everywhere in my studio. But none of these protocols was designed to send video over the lossy networks like internet. And therefore, every time you use protocols without error correction, your video will exhibit something like this. And I actually collect these pictures, and they often post it on forums on Facebook, and customers ask, what is the problem? What do I do? Which settings should I change on sending or receiving side? It's really not about settings. It's more about the protocol. And if protocol doesn't include error correction, if protocol is not resilient to data loss and jitter, then sooner or later your video will exhibit things like this. And this is not something which you'd like to have at the output of the decoder. So that's why we're so excited about Secure Reliable Transport Protocol, the SRT, introduced by Haivision. The SRT protocol is quite unique. It was designed for sending video over the internet. The protocol is completely bidirectional. The encoder sends video to the decoder, and decoder immediately confirms it sends stream quality confirmation back to the encoder. Decoder also detects missing data, and every time missing packets are detected, decoder would send repeat request all the way to the encoder. Encoder will issue the replacement data, but just those little chunks which were lost. And this replacement data will be inserted in the stream by the decoder, and as a result, output will be absolutely perfect video despite of packet loss. We always test all video protocols in our labs for packet loss, for jitter, for latency, and in our tests we were able to compensate for up to 30% of data loss using SRT protocol. Think about 30%. It's 1/3 of your stream is gone, but you're still looking at the perfect video. Of course, the process of asking for replacement and sending replacement, this algorithm takes time. And therefore, the efficiency of error correction depends on the latency allowance. And the reason I call it allowance is that you dial latency in manually in the camera, and you can set latency to anywhere in between 100 milliseconds and 8 seconds. And that's how much time you're willing to give this protocol to ask for replacement and to insert replaced data in the stream to assure that you have no dropouts or no artifacts in the video. You don't need to go that crazy as 8 seconds. Typically, latency for SRT is set anywhere from 500 to 1000, which is from half second to 1 second. And there should be enough time to recover most of data loss using standard internet connection. Another aspect when you send video over the internet is image quality. And while you can argue that image quality is subjectional and it may be described by the sensor, lens, there are certain numerical values which are used to describe the fundamentals of image quality. And this is video resolution, video frame rate, color space, video audio levels, and also audio quality and latency. When you select an 8060p in the camera and push live button to start this transport, and then measure output of the decoder, which could be 5,000 miles away from the camera, you will find 1920 by 1080, 5984p, ITU 709 or 2020 color space. It is selectable on the camera. And levels for audio and video could be either auto or manual, they can be preset. And also audio is high quality stereo AAC codec. When you compare this to other ways of sending live video, and because quite often customers ask me, say, Edgar, you're talking about so many things, it seems to be complex, but I just use Zoom and I just use remote, I talk to remote contributors via Zoom and it works great. Well, first of all, nothing wrong with Zoom. These people do an amazing job of providing communication for millions of people. But if you think about WebRTC protocol, which is used by Zoom, Skype, GoToMeeting, really none of these parameters are specified or guaranteed because everything changes over time. Video may start pixelized and then improve and then become pixelized again. It may start at 30p and then go down to 5p. Audio, it's also, they do their best effort to assure communication between many people with very low latency. But obviously, when we're talking about image quality, there's no guarantee of any of those parameters. While SRT, all these parameters will be the same, will be constant throughout the entire time of your video transport. And of course, it comes at the cost of anywhere, when you use internet as a media, anywhere from 1 second to 2 seconds latency is required to deliver all this information and to correct all errors and data dropouts. WebRTC is lower latency, it's almost no latency, but none of parameters, resolution, image quality, it's not guaranteed and it changes dynamically. So it's important to understand the difference between SRT transport and WebRTC. Return video over the internet. In order for connected CAM series camcorders to receive return video over the internet, video needs to be encoded at the studio. This example shows GYHC 500 camera on location and studio, where we're using KiloView E2 encoder, which is equipped with the HDMI inputs to take direct output of the computer running prompter software. So this encoder encodes H.264, 720p. Camera supports return either 720p 30 or 60p, up to 3 megabit. So encoder encodes this video and makes it available for camera to pull from remote location. Up to 10 cameras can pull a return from single KiloView E2 encoder with HDMI inputs. Additional encoder or separate feed may be needed for return video as a program output from the switcher. In that case, we recommend to use KiloView E1 encoder, which is equipped with the SDI. Same thing, SDI output from the switcher goes in the small encoder, and encoder encodes H.264, 720, 30p or 60p, up to 3 megabit, and this feed will be pulled by up to 10 cameras. The third option for return is to use only return audio, because some customers may not need to use return video, but they'd like to take advantage of return audio. First of all, return video includes 2 channels of audio with every video feed. But like I said, in some workflow applications, you may not need video, while you'd like to have return audio as a channel of communication between studio and talent and cameraman. For that case, we recommend to use Diva DB91TX IP audio encoder, which takes a pair of stereo audio output from the audio mixer and makes it also available for camera to pull using IceCast protocols, and up to 10 cameras can pull a return from a single encoder. The IFB return audio features high-quality AAC encoding using IceCast protocol with a very low bit rates, from anywhere from 24 to 44 kilobit, and you'd be surprised at such a low bit rates that the sound quality is much better than cell phone. Well, with all the tools and features built into every single camera, remote production over the internet becomes something very simple. With the cameras in the field connected to the internet switcher, either via LAN or Wi-Fi, all you need to do is just to push online button, and camera will be sending broadcast quality SRT transport to the remote studio, simultaneously receiving return video, prompter, return audio for IFB. They can be controlled remotely over the same connection, and multiple SRT streams can be synchronized utilizing built-in timecode, which is synchronized by each camera with the NTP clock. And what is important to remember is that none of these services come with any subscription fees. With a regular internet connection, you can be sending broadcast quality video for 24/7 with no added cost. And finally, just like to remind you the products which we used in this demonstration. So first of all, the lineup of connected camcorders, GYHC 500, 500 SPC, and 550, shoulder type GYHC 900, BRDE 900 decoder, which can receive SRT and output 3G SDI, BREN 900 encoder, which does opposite actually. It can be used when your video source is not a camera but a mixer or something else. It can receive 3G SDI and output SRT. We'll be using vMix for this demonstration, but we offer also JVC CAM IP series video switches which support SRT, or there's also NewTek TriCaster which adopted SRT protocol. And for return video, we recommend small and very nice little encoders from KiloView, E1 with the SDI inputs and E2 with HDMI, convenient for return video and prompter. Well, that concludes my presentation. You can see my email address. Please send me your questions, and I will be happy to talk to you via email and to help you with the remote production over the internet workflow with JVC Connected CAM streaming cameras. Thank you very much. Goodbye.